you have something like this, and some of you were getting the parentheses, and some of you weren't. So if it says something like 2 times the difference of x and 3, let's see, this is going to be right. Oh, I didn't do that. And now I'm doing this. Okay. Pause. Anyway, if we have something like 2 times the difference of x and 3, we're multiplying that 2 to everything. And the only way to show it's multiplying to everything is if we have. So if you didn't use parentheses, it counted you wrong. Or if you used the parentheses incorrectly, it counted you wrong. Khan Academy is also picky, so be careful with how you put stuff in. But if I had something like this, or less than the product of 1 and x, remember that less than is that turnaround phrase, so I'm putting whatever comes before that at the end. And I'm just subtracting that from me multiplying 1 and x. So there were a lot of you who did well. Some of you had to try a couple times. If you are still struggling with that, please let me know. We can go through any of that together. Anyone want to share their answer for number 1? A lot of you had very similar things with some differences. Just go ahead. Multiply by the sum of what was the rest of that? A number and 3. I'm using the hashtag for number, but same thing. Some of you wrote out -4. Some of you said -4 times the sum of, and then a number and 3. Some of you switched this and said the sum of a number and 3, all multiplied by -4. All of those would work. Okay. Who had something similar or the exact same thing? A lot of us. Good. Anyone else want to share theirs to see if theirs would work? We're going to go through 3, and then it'll probably be time to lunch. The difference between a number and 5. Anyone want to share their answer for that one? Nature, go ahead. Alex, you do the next one.
X minus 5.
So the difference I'm subtracting between a number, my variable is going to go first, and 5. You could have a different variable. You don't have to have x. But it should be somewhat in that format. You have that same thing or something similar? Okay. Alex, did you want to do the next one? You said 5 minus x. Okay. Be careful with this one because that less than means this 5 is going to go to the end. So this one is actually going to be in the same format as the first. So if you had 5 minus x, go ahead and switch that x and the 5 around, or whatever your variable was. Who had x minus 5? A number less 5. Anyone want to share their answer for that?
Someone's like afraid now.
I'm gonna write it.
Same.
This one is the same. So less doesn't mean the turnaround phrase. Less than does. So a number less 5 means exactly what it says. X minus 5. Right. The difference between 5 and a number. Christian.
5 minus X.
5 minus X. That one would be different because the number, or 5, comes first. So with your difference problems, we want to write it exactly how it says. Alright, when we come back. Alright, when we do this algebraically, we're looking for like terms. So they have to have the same variable. Could be positive, negative, that part does not matter. Or they have to not have a variable at all. So in this one, our like terms would be our x's. So when I do this, I try to use different colors and different shapes. So I might circle all of my x's or square all of my x's and then circle all of my constants. So we have two sets of like terms, our variable terms with x and then our constants. And when we do this, the variable terms, we're really just taking the numbers in front, seeing what that would be, and then at the end, put x at the end. So negative 2 plus 3 would give us what? 1. And then I would add x to the end. Negative 2 minus 1 would give us what? And we can say this out loud. Negative 3. So our final answer would be 1x minus 3 or x minus 3. A lot of the times you won't see that 1 in front. You can still put it for now if you're more comfortable with doing that. But we're going to start to move away from that. Do we have any questions on how we did that? Or how we got that answer? Some of this should be somewhat familiar to you. Some of you may have not seen it. Does anyone still need this? Okay. Let's do another example. What are the like terms here? Someone raise your hand, or if I have an answer. What like terms do you see? With each of these x's, there is a 1 in front of them. The x and the negative x, I should say. So we're going to combine all of those. 1 minus 2 minus 1. Figure out what that is and then put x at the end. What would that give us? We can say this out loud. So these two would cancel to make 0. But there'd still be a negative 2. Or if we did it in order, 1 minus 2 would be negative 1. Negative 1 minus another negative 1 would be negative 2. And we put the x. Shortly, we're going to stop doing this process and just kind of combine them in our heads. Negative 4 plus 2. What would that give us? 2. So our final answer would be negative 2x minus 2. Questions on that one? Does anyone still need this? I think there's one more on that same page. We're going to do that one. Someone tell tell me like terms you see. One pair of like terms you see. Nature.
X squared.
Which ones?
Oh, sorry. Negative 3x squared and then positive x squared.
Okay, so that is a set of like terms. Keep on. 2x and negative x. And then our last ones, triangle these, are positive 3 and negative 2. So if we are combining all of these together, we have to remember that these still have ones in front of them. Order in which you write these, exponent or highest exponent goes first, and then we decrease in exponents, and then variables, and then those without variables. So negative 3x squared plus 1x squared. How many x squareds would that be? We can say this out loud. I heard a voice, but didn't hear what he said. When we're combining the x squares, it'll be very similar to when we combine the x's. We're just taking the number in front, adding or subtracting those, and then putting x squared back. Alex? For these two? Negative 3 plus 1. Iman? Negative 2x squared. So I'm going to write it. Negative 3 plus 1. And then add the x squared. 2x minus 1x will give us how many x's? 1x. And I'm going to go back and write it just so we have it up here. And then 3 minus 2 would also give us 1. So we're putting everything all together. We have negative 2x squared plus 1x, or just plus x, and then plus 1. We did this one with algebra tiles before, so that answer should be the same as the one previous. Nature. We are not gotten to that yet, but hold that question. Alright. So on this next page, I'm going to do a couple of these with you, and then I want you to try some. So we're going to do number 4 and 5 together, and then I'm going to let you try some, and then we'll move on to next. First, I should say this. These next two that we do, you won't really be able to use algebra tiles with them because we would need something with 2 different variables, and the tiles I have don't have 2 different variable ones. 5, we couldn't use algebra tiles because we don't have fraction or decimal algebra tiles, but some of these other ones you could if you wanted to. When we write this answer, if we have more than one variable, write them in alphabetic order as your final answer. Do we have like terms here? If you have an answer, you can raise your hand. Josephine. For number 4. Negative 6a. And negative 5a, let me So if I were to combine those two, negative 6 minus 5 would give us what? You can say this out loud. Negative 11. And then we would put a behind it and bring everything else down. Do we have any other like terms? We have an A, we have a B, we have a constant that doesn't have anything. So this would be our final answer. It cannot be simplified any more than that. Do you have any questions on that? For number 5, even though it has fractions, we're still going to do it the same way. Do we have like terms here? Yes. What are they, Christian?
Negative 2 over 3p and 5 over 6p.
And then even though they look different, one's a fraction, one's a whole number, these are still like terms. So we are going to get in the habit of doing this by hand. Not that you won't have your calculator for this task, because you will, but moving forward, there may be some sections of tests that are non-calculator, which means you would not have access to your calculator at all. Really, because if you start to move on to higher level maths, some of those have no calculator version tests. So this is a good practice to start doing that. If we were to combine these two first, could we combine these as is? No. What do we have to do to them first? Ava? Change the denominator so that they're the same. We could make them both be 6, since 3 is a factor of 6. What would I need to do to 3 to get it to be 6? Alex, multiply it by 2. Multiply it by 2. So if I multiply this by 2, what I do to one piece of the fraction, I also have to do to the other. So what would this fraction become? 4, 6, negative 4, 6p. And we're adding that to 5, 6p. We're going to do that here in a second. For the 1/5, I don't remember if I mentioned this in this class or not. Anytime we have whole numbers, we can make those into fractions. All whole numbers that you know really have an invisible 1 underneath. So what would I multiply this by to get it to be the same? Cameron. Nope. Yes, Cameron. I would keep mixing you guys' names up. Sorry. 5. And then I was like confident, and I was like, nope, I messed up her name, and it was the right name. Anyway, multiply by 5. So this fraction would become what? What would this become? Negative 5 over 5. Now, both of these sets of fractions have the same denominator, so we can actually combine them. Negative 4, 6 plus 5, 6, we are just doing our numerators. We are not touching the denominators. How many p's would we have? Alex, 1 over 6? Is that what you said? I said 9. So this was negative 4. Oh. To be negative 1/6p. And when we add these or subtract them, we get what? Negative 4/5. So our final answer for that one would be negative 1/6p minus 4/5. Do we have any questions on how we got that process? When you're doing problems like this, if you want to double check yourself in your calculator, I'm going to show you how to do that. So in your calculator, if we wanted to add together negative 2/3 and 5/6, everyone do this with me. Go into alpha y equals. So alpha should be in green, y equals is up at the top. Once you do that, this menu should pop up. And you're going to choose the first one, n over d, that's your numerator over denominator. You can hit 1 or you can hit enter. And you should get a fraction bar. It was negative 2/3, so I'm going to scroll to the left in front of it and put a negative sign, which is the one at the bottom, not your minus. And then scroll back to the right and put in my fraction by just using my arrows to move around. And then if I move to the right, I can get out of that, hit plus, and then go back and do this again. Alpha y equals, grab my fraction, 1 or enter, and put in 5/6. After you have that in, hit enter, and it will tell you what the answer is in the most simplified version of it. I didn't need it with negative. It was done with positive. Right. Anyone need to see how to put that in the calculator again? Okay, I'm going to do it with the other fraction. We had 1/5 minus 1. So I'm going to go back and do alpha y equals. Go back and grab my fraction bar. Put in 1, scroll down, and 5. And then minus 1. And I can hit enter, and it will tell me what that is simplified. Right? So that's a good tool to double check yourself if you're not sure. We'll be going through more calculator decimal stuff later. Okay. There are 3 problems on this I want you to try. Number 3. Number 6. And number 7. Try those 3. I'll give you 5-ish minutes to do that, and then we'll come back and we'll talk about them. For number 3, anyone want to share their answer for that one? Hima. 14t minus 5. You heard of the same thing? Good. This was the correct answer. You should have added these 2 together to get 14, and then just put down the minus 5. Anyone have questions on that one? Who wants to share their answer for 6? We're not as confident on that one. But I saw a lot of good answers. Lisa. Negative 0.75k minus 2. Who here had the same answer? The majority of us. Anyone need to, well, this one is working it out part. Make sure that this has a 1 in front of it. It's just invisible. So you'd be subtracting these 2 and then subtracting these 2, and you get negative 0.75 and negative 2. Questions on that one? For the last one, anyone want to share their answer for that one? Matthew.
So it'll be Q minus 7/12.
You are partially correct. There is a Q, but it's not just one Q. And then you said minus or plus?
Minus.
In this case, the numbers that you have,
Plus.
you're going to end up with a positive. What should we have in front of that Q? Josephine. So I saw a lot of 4/6, and you're super close. You just need to simplify that. We want to simplify as much as possible, always. Some of you have this term over here. So just make sure you have that first. 2/3 q, and then plus your 7/12. Anyone need to see how we got that? We're going to move on to the next portion of our simplifying, which is distributing. Does anyone want algebra tiles to use? If you change your mind, let me know. I'm going to do a couple of these with the algebra tiles and then algebraically as well. If you are drawing them, you do not have to, but if you did want to draw them, make sure you are drawing the negatives as shaded and everything else as just a rectangle or a square. That would show positive versus negative. Alright, we're going to start with this example. If I was representing this using algebra tiles, I'm going to start with the inside. X plus 2. How would I represent that using these algebra tiles? Yeah. And since this entire thing is being multiplied 3 times, I would need 3 sets of these. So what do I have here in total? We had to count up all of the x's and all of the 1's. What would we have? 3x plus 6. If we were doing this algebraically, we take the number out here, multiply it to every number in here. Remember, there's a 1 in front of the x, so that's really what we're multiplying it to. 3 times 1, we can say this out loud, would be what? 3, and then we would put the x behind it. 3 times 2 would give us 6, and it's positive, so this would be plus 6. So we get the same answer either way, just the algebra tiles take a little bit longer. Questions on that one? Anyone still need this before I scroll down? Let's do the same thing with this. How would I represent this inside with the algebra tiles? So red rectangle, a yellow square, and this is being multiplied by 2, so I would need 2 of these. What all would I have here in total? Negative 2x. If I were to do this algebraically, same thing as before, I'm taking that 2, I'm multiplying it to both of the numbers here. 2 times negative 1 would give us, we can say it out loud, negative 2, and we would put x behind it, and then 2 times 1 would give us that positive 2. Okay, so these are more of the easier ones that you'll probably see. And let's do some more complex ones. Skip a couple pages until you see this one. Maybe not a couple pages, maybe just 1 page. Alright, this one I'm not going to do algebraically, with algebra tiles, just because there'd be a lot going on, we'd have to get rid of stuff. You still could, but I'm just going to show you how you do this algebraically. And there are 2 different ways that you could do this algebraically, or by hand. One would be to, inside our parentheses, we have like terms we can combine. So let's do that. we have x's and constants. So if we were to combine those, what would our new inside be? Negative 2x plus 5. And then just as we did before, we would take that 2 on the outside and multiply it to everything inside. So 2 times negative 2 would give us negative 4x, 2 times 5, 10, and it's positive. And that would be our final answer, negative 4x plus 10. Questions on that before I show you the second way we could do this? Now the second way, I'm going to rewrite this problem down here. Let's say we were looking at the problem and we didn't think to combine our like terms first. And we were just thinking, I have a number on the outside, I can distribute. It'd be a little bit more work, but you could do it this way. So if we're distributing, 2 times negative 1 would give us that negative 2x. 2 times 3 would give us 6. We'd have another negative 2x, and then 2 times 2 would give us 4. But this is not simplified. We still need to combine like terms. So if we were to combine negative 2x and negative 2x, we would get how many x's? Negative 4x. And 6 plus 4 would give us 10. We get the same thing either way you do this. So as long as you do both steps, the distributing and the combining like terms, the order there does not matter. Questions on that one? Does anyone still need this before I scroll down? What do we think we would do first here? Lisa. Distribute the 3 to both of these things. We are still going to do that, but could I combine these two first? No, why not? Alex? Correct. So if you're thinking, why have like terms here? You do, but this is like in a bubble. You can't go inside this bubble until it's gone. So multiply this out, so we get negative 6x minus 3. Bring down your plus 4x. And then our next step would be to do what? Someone whispered it. Combine like terms, which are our negative 6x and our positive 4x. So if we combine those, we get what? Negative 2x minus 3. Questions so far? Okay, we're going to do, I want to say 3 more examples, and then you'll have time to try some on your own as well as work on Khan Academy. So on the next page, we're going to do both of these. Still doing the same thing, but now there's a lot more. So we just have to be careful, make sure we don't lose anything, all of our math is correct, and all of those things. There are 2 sets of parentheses. We can distribute those both at the same time. So what would this first set become after we distribute? 4x plus 8. We would bring down this negative 3x, what would the last part become? Matthew, go ahead.
Negative 2x plus 3 plus 6.
Plus 6. So anytime you have that positive, negative thing going on, just put minus, don't put plus minus. Right? Now we can combine our like terms. What are all of our like terms? Mom. 4 minus 3 minus 2. How many x's would that give us? I heard it. Matthew?
Negative 1x.
Negative 1x. Or just negative x. And then 8 plus 6 would give us what? 14. So all of those things condensed, simplified to become these two terms. Negative x plus 14. Any questions on how we did that? How we got that answer? Does anyone still need this? Let's do this next one. Same as before, we're going to do these at the same time and make sure we bring down everything. As we start to distribute, what would this become? You guys can start saying it out loud. Negative 6x plus 2 plus 6x minus 3, and then we bring down our minus x plus 2 at the end. Make sure you bring that down that last part, because if you lose it, it will change the answer. All of our like terms, we have negative 6x, positive 6x, negative x. How many x's do we have?
Negative 1.
Negative 1. You guys can say this for now. I'm sorry. And then our constants, we have 2, negative 3, and 2. That would give us
Negative.
not negative,
No, just 1.
just 1. Simplifying with distributing. How do we feel about that? Good, okay, probably need more practice, not good, I don't understand. A lot of goods, some okays. I don't see any not goods unless I'm just not seeing your hand. Okay. So we're going to do one more example together. Does anyone still need this problem? Yes. Yeah. We're not going to do number 1 on the next page. I just want to say something, help you out, give you a hint. This, behind this minus, is a negative 1. So when you're distributing, you're multiplying by a negative 1. So keep that in mind. We're going to do number 5. So we are still distributing, we just have fractions within that. When we distribute two fractions, think about this 2 as a fraction itself. You are just multiplying across, so the 2 with the 1, the 2 with the 2, because 1 is being multiplied to the denominator, so it's going to stay the same. If I was multiplying 2 by 1/5, what would that give us? 2/5. 2, there we go, 5/5, times negative 2/5. Negative 4/5. Bring down your 3/5 at the end. Here we have like terms, just your constants. So the 2/5 m would stay the same. Negative 4/5 plus 3/5 would be how many? Or would be how much? I heard negative 1/5. So 2/5 m minus 1/5. Do you have any questions about that? Correct. So I'm going to give you a few problems to try. If I could speak today, that'd be great. Really just a couple. Number 6 and number 7. Try those two problems. We're not going to go through them today. We'll go through them next class. But try those two problems. Once you finish, you can work on your Khan Academy. The ones that are due Friday. If you still need to fix the one that's from last week, you can work on all of those. So you'll have the rest of the class to work through those two and then try your Khan Academy.